Hello, everybody. I'm Philip, and I like load balancers. All right, what do I want to talk about? I would like to talk about DeepL first, what we do, what makes us different, and then a little history of our infrastructure, followed by basically the current state, and then a little look in a possible future, maybe. Let's see. All right, about us. DeepL was created in 2017. That's not so long ago, and we provide AI-powered machine translation and writing assistance services. Our translate service has about 30 languages. It's really a matter of how you count them, so it's 30 plus. And Write currently supports 4 languages, but it's increasing every once in a while. DeepL was not entirely new. It emerged from an online dictionary company. If you look up our Wikipedia page, you can see what I mean. So HAProxy is actually being used in this company if you count the online dictionary since 2013. All right, what would we like to talk about? Since about 2019, so two years after its inception, DeepL's business grew exponentially. And with it, the number of developers, web services, machines, data centers, changes in the infrastructure, requests per second, traffic spikes, and attacks. And, well, it was exhausting. It was challenging. This is how especially we operators felt at the moment, or during these years, actually. So there were technical challenges, but more interestingly, organizational challenges. So we constantly were facing questions like how to enable developers without requiring them to know the infrastructure, especially if it's shifting around and changing all of the time. They are not supposed to know that. They are supposed to actually focus on what they're good at and not keeping track in, hey, where do I need to deploy this? Also, how to how to not enable developers too much, because they might shoot themselves in the foot. So this is actually what the meme over there is referring to. Please raise your hands if you had this kind of situation as an operator. Okay, at least a few. All right, also how to enforce best practices and how to avoid organizational bottlenecks, and that was specifically challenging, especially challenging. So how does HAProxy actually fit into all this? This was a rather generic problem, right? So load balancers are affected first by growth issues. So for example, you have more traffic, scale up the load balancers. You get more abuse suddenly. Stop it at the load balancer. Please don't let it come up to our applications. You get more endpoints. You suddenly have to manage a bigger load balancer config and come up with new solutions to that. You have more teams, and suddenly you have to think about something like blast radius. How do I keep one team from messing up the configuration for another team, or bringing down the entire load balancer? This is also possible. And of course, compliance. When you grow, then you have compliance, and then you need to think about things like a web application firewall, bot management, all of these things. And so HAProxy was involved in, but also solution to, a surprising amount of growth issues. All right. So we started out small. We are still mostly on-prem. But back then we had basically 2 bare metal machines on-prem co-location, and those were an active-passive pair of machines, and they both just had internet uplinks, and we had an Nginx on them, and it reverse proxied basically to web content, business backend, think about payment and stuff, and our translation API, and the translation API, of course, talked to all our GPU workers. Why Nginx? There was no decision. It was, we need to serve web content. We have an Nginx. We need to do some load balancing. Well, Nginx can do that as well. It's fine. So it was at that time no deliberate decision. So there's no HAProxy yet in the picture. Again, on our old online dictionary it is, but not here. All right, so we started hiring a lot, and we had more teams, and via Conway's law, we had more web services. And you see it in the diagram. We suddenly have something like Write API, Glossary API, Analytics, Geolocation, and so on and so forth. And the list just grew. And it was still all on that machine, by the way. But it was quite beefy. So we had a larger Nginx config, and it quickly became unmanageable without having some templating. And the templating was done by config management. But with templating, it comes additional mental load usually, this led to developers saying, "Hey, I actually know how to do Nginx things, but I tried something. Can you review it, please? I'm not sure whether this works. I'm not familiar with your config management system. I do not know how it deploys. Can you have a second look?" Or most often, this is too confusing. Can you just do it? Like, I would like to have that subdomain. Just do it, please. And this is the DevOps everybody is talking about. To reiterate how it was, developer wanted to do something, developer got intimidated, developer asked us, we had to do it, and we had also to coordinate with the developer. So we said, okay, can we deploy now? And maybe the developer was then at lunch, so we had to put this off, and maybe I was at lunch when the developer came back and so on. Like, it's unnecessary. So how it should be, like this. Developer wants to make changes, does them, done, and the operator has hands-free to do something else. So how do we get from left to right? We had to make it simpler somehow, so developers got the confidence to make changes themselves. So first step towards that was, actually, we were not happy about Nginx and how it did configuration. And because we still worked with HAProxy for our legacy online dictionary, we knew HAProxy, and there were certain aspects we liked about it. The first and most important one was no extra config to enable keep alive connections toward the backend servers. I do not actually know how it's now with Nginx, but back then you had to include like several lines for each upstream to make sure a keep alive connection pool was established. And if you didn't do this, then you learned that problems like ephemeral TCP port exhaustion exists, and you have a lot of fun to find out why that happened. Yeah, we also like that you could load search just from a directory. Like with the growing number of services, we had more subdomains. We needed more certificates in certain cases because we also had subdomains, and wildcards didn't cover that then. So we could throw it all in a directory. And it worked. This is more of a personal thing. It's less for my colleagues, but I really liked about HAProxy back then that the no request modification was done unless explicitly configured. Not like, for example, the proxy path directive of Nginx, which sometimes rewrites the host header and things like that. I think it's unnecessary. Yeah, the front and back-end concept was easily understandable, and things usually happen in the order they are defined. I'm aware that there are also request-response phases and other phases between them, but usually you can just read the config, start here, go there, and you usually have understood how a request is processed. Also, from the get-go, we experienced great support on GitHub. So thank you, Willy Tarot and Christopher Follet and all the others who always jumped on an issue when I opened it. And also thank you to Vincent Bernard for providing well-maintained packages. All right, so it kind of worked. It made changes easier in theory, but mostly for operators, because they had to learn how HAProxy worked, and they were happy with that. But developers usually were familiar with Apache, Nginx, like all the web servers, but pure load balancers, that is nothing they usually encounter during their day. And they had to make an extra invest to do it, and not everybody wanted to do that. So basically, it's the same graphic, but this time get intimidated for different reasons. So it didn't change that much, sadly. So we needed to do it even simpler. This came at a time where we had to make more things simpler. We had to simplify provisioning of storage, auto-scaling, reserving of resources, provisioning, and access control. Yeah, for us, Kubernetes was the obvious choice. So there were already ingress resources as the main source of load balancer configuration. And yeah, the HAProxy ingress controller already existed back then. I looked it up. But we went with the standard Nginx ingress controller a little bit for the same reasons as we stuck with the Nginx in the first place, because it was the standard, the default, the safe option, and we just wanted to get the cluster off the ground because we had our hands full. Yeah, as you can see in the graphic, we basically had still our beefy machines, but we started to migrate all our apps to the Kubernetes cluster. And I just wanted to illustrate. Think you're a developer, you just want to get your app online, you do not care about the rest. On the left side, you have an HAProxy config, or maybe you get some abstraction in config management of that. But the point is, you see like the global options, the default options, all the things that are in one or more front ends, and then you have to add like an ACL and a use backend in there, and then you have to add a backend in there, and you see all this clutter in your point of view. And yeah, on the right side, there's an ingress resource. You can basically just give it a name, add a domain, and in most cases, you just need to know your service name and port name, and you're good to go. All right, so we migrated everything to our Kubernetes cluster, but then we had a new problem. We had a redundant proxy cascade because we had basically two L7 load balancers in a row. The first one had all the neat little things we put in the configuration over the years, and the second one was just a more or less dump forwarder of requests, and it was really unnecessary. It wasted a lot of resources. And debugging also did not get easier with that. We had some issues with HTTP2 between the two sometimes. And yeah, most importantly, sometimes developers did not only have to create a ingress resource, they also still had to make changes to the HAProxy configuration. So our goal was, we wanted really to enable devs to route public traffic with a single ingress resource, and then you're done. Okay, so how does it look today? Maybe one more thing I should tell. We actually coupled two things. We wanted to get HAProxy as our own ingress controller, ditch the old hardware load balancer, or the bare metal load balancer in front of it, which also had HAProxy. But we also got the issues I described earlier, most notably the compliance issues we had, but we also wanted to have better rate limiting. So we really wanted to have stick table aggregation via a global profiling engine. So we said, okay, we have to do a big project anyways. Let's just get HAProxy Enterprise and do both things at once. And this is what we did. So on our existing Kubernetes clusters, we installed HAProxy Enterprise Edition as ingress controller. And yeah, in the previous graphics, I left out the router because it wasn't that important, but here I think it's a little bit more necessary to show it. So on each node in our Kubernetes cluster, we have a neat little application, MetalLB. You might have heard about it, and it announces the public IP of HAProxy via BGP to the router, but only from nodes where a Kubernetes ingress controller is actually present. This is a specific load balancer service setting you can set. And yeah, then only the nodes with a Kubernetes ingress controller get actually traffic directed by the router. And yeah, each HAProxy Kubernetes ingress controller has a sidecar with a tool called Vector. Vector is a log processor, and what we really like about it, it's written in Rust, it's very fast, and it can aggregate logs to metrics. So we can actually get a lot more metrics than the original HAProxy or HAProxy ingress controller offers, and we can really customize it to our needs. Yeah, and the rest is well known, I think. Like the HAProxy ingress controller knows about all the apps we have, and then it does load balancing. So I talked about how to avoid bottlenecks. One of the bottlenecks we eliminated first was abuse protection. We have a dedicated abuse protection team, and they are the owners of our block list and gray list and whatnot. But they still had to go over our config management, our repo, we had to approve it, and it's like, yeah, you probably have your reasons to put that IP there. I cannot really vouch for anything. And we rubber stamped it basically, and yeah, then you can just eliminate it. And this is what we did. We created a Git repository with all the block lists in there. Then we had a CI/CD pipeline. And when it was successful, we uploaded all these files to web server, and then we used the HAProxy Enterprise LB update module, and it pulls new block lists every minute. So rather simple stuff, but yeah, it works. The best thing about that is we never hear about any issues. When somebody remembers from earlier days that that we did that, we just say, hey, there's another Slack channel for the abuse protection team. Just do it over there. They can make all the changes you want, and you never hear from them again. So we have our hands free to do something different. Yeah, and for future work, we would like to do the same or something similar with HAProxy Enterprise Edition WAF rules. We are currently using the WAF in learning mode. It's not really active yet, but yeah, we are currently learning with that. Right, yeah, we established some shoot-in-the-foot protection via a tool called OPA Gatekeeper. So OPA stands for Open Policy Agent. And the Gatekeeper tool is really nice because you can basically add additional validation for any kind of resource the Kubernetes cluster offers. And we wrote us a little validation rule for the backend config snippet. It's a specific ingress annotation for HAProxy where you can put configuration verbatim into the backend. And this can be dangerous. For example, if you just say, hey, I raised the log level, then suddenly the requests, like a very detailed request log is sent to standard out, and then it's collected by our log conductor, and then it's shipped to our logging system, and yeah, like half the company can read that. So not good. Yeah, so we have the gatekeeper rule to check for allowed directives. So we basically go on a allow list approach. We say, okay, we found a new use case. Okay, for that use case, we need that statement. So we put it in the regex list. TLS management, yeah. There's no TLS management. It means that developers actually never have to fill out the TLS part of their ingress resource. We have a default certificate. The default certificate has a lot of subject alternative names. And they have to adhere to certain conventions regarding domains and subdomains anyways. So all our wildcards just cover it. And yeah, that's nothing they have to worry about. Also, they do not need to think about having a TLS redirect. It's hard-coded. They can't have it any other way, even if they try to disable it. It's always redirected because we don't think there's any valid use case for public traffic to go unencrypted. So 2 more sources of error eliminated. So we got, yet again, more time on our hands. And finally, we added some nice information to every request via 3 modules from HAProxy Enterprise, geolocation, fingerprinting, and bot management. The information is like you can either just ignore the header or you can like make a more elaborate decision what to do with that request. Yeah, by the way, we tried it with enabled and disabled, and from a latency point of view, it didn't make any difference, so we left it on. Okay, so we already we are now in the future. There's one or let's say a few things that would make our dream of a perfect platform complete, and HAProxy can help with that. So we currently have the problem that HAProxy is actually a very powerful tool. Every time a developer asks me, hey Philip, we have this weird use case, can HAProxy do that? And I usually say, yes, 2 lines, boom, what's for lunch? But Yeah, the problem is that the Kubernetes ingress controller is an abstraction on top of that. And as abstractions only often do, they only offer a fraction or expose only a fraction of the functionality that HAProxy is actually capable of. As a escape hatch of that, you have the backend config snippet that I mentioned earlier. And here's an example where you, for example, can restrict the maximum body size. This is something which is not offered as an annotation. So currently, our developers, like I documented this and basically say, hey, please copy paste this into your ingress and change the number to what you like. And yeah, I hope it doesn't break. Problem is, it's a little bit overwhelming for developers. It's error prone. Maybe they change the number to something which does not make sense, or accidentally remove a comma or whatever. And it's really hard to validate for a developer whether they did the right thing. So the thing is, of course, in this case, I could just go to HAProxy Technologies and say, hey, can you implement that for us? Then it's yet another feature request. You guys have been awesome, and it was always very quick, but you're also only humans and have limited time on your hands. So the problem is, if you really want to implement all the HAProxy functionality all the time, then at the end, when you're done, Willy Tarot pushes out a new HAProxy version, and then you start from scratch, right? You have to implement all the new or changed functionality. So we actually propose something different. Let us operators help to do at least a part of that for you. So let's imagine we want an interface like this. We have two annotations, max body size bytes and max body size deny status. This should basically implement what I've shown you before. You have the snippet, but now you have nice little annotations. And the developers don't have the mental load of thinking, did I do this right? Like, it's okay, copy, paste the left side of it, put a number on the right one. Okay, there's not much I can do wrong. Yeah, maybe missing the quotes, but yeah, that's Kubernetes for you, or YAML for you. As a way to administrate that, I would suggest let's use the config map we use anyway to configure the HAProxy ingress controller, and add a new key in there, which is called custom annotations. The good thing about this is a space only administrators can edit, so we can be sure that people who at least know a little bit what they're doing can edit. And just imagine we have two keys in there, max body size bytes and max body size deny status, like the two custom annotations, maybe some validations, a default value. And the most important part is some templating snippet. I used Go template here, but yeah, I don't really care. It's more about like some templating engine is there. And then you can say, okay, if the annotation even has a value, then please render this and put like the annotation value there and the annotation value of the other annotation at the other place. And the other annotation doesn't have a template, but it has a regex validator where you can say, okay, only 4xx status codes make sense in this. This is, of course, just a suggestion how something like this could look like. But yeah, in the end, the problem is we would like to offer our developers a simple and safe to use interface to unlock the full potential of HAProxy. And there are so many use cases I think no HAProxy developer even thinks about, and I get confronted with them every day. So I think it's very unlikely that all of them would get implemented upstream, because some of them only make sense for us and nobody else. Some more examples. We have customized access logging, and maybe we want to add a field, but we want to have a JSON encoded, so it can be put into a JSON field in ClickHouse, for example. Or we are using the GPE, but it's not officially supported yet, I guess, in the ingress controller. So we do it like ourselves, but then you need to modify different variables to actually make the rate limiting work. This could be also exposed via custom annotations. And recently I looked at the canary deployment feature, and you have to add an annotation on the servers. people are used to put an annotation on the ingress. I don't think that every Helm chart at DeepL even has a feature for putting annotations on services, so we would have to put it, re-implement that there, and things like those could be part of the use cases for something like this. So in the end, operators could ban backend config snippets and just selectively expose functionality that they deem to be safe. And HAProxy technologies can remove itself from being the bottleneck for exposing new HAProxy options. As I said, it's probably not ever going to happen that every functionality is exposed as a combination of annotations. And as far as we know, maybe somebody is going to prove me wrong in the next 10 minutes, but I think no other ingress controller actually offers this feature. All right, that's it. Thank you very much.
Awesome. Thank you, Philip. So we do have time for a few questions. Again, just raise your hand nice and high and we'll get a microphone over to you. We did have a few come into the chat, so I'll start with those. What sort of syntax checks do you do on those block lists?
As you've seen, it's more or less a rather crude regex. We usually say, okay, like HTTP request, deny, dot, star, for example, we can say, okay, you can deny request. And this is part of the problem because it prevents the worst, but it's absolutely not foolproof. And this is actually part of another feature request we have, which is called validating webhook, where the whole configuration is sent before to HAProxy before it is accepted into the Kube API server, and this would catch really all of the errors. So the OPI gatekeeper thing is nice, but it is a band-aid mostly.
There was a question. Is Vector your own application, or is it open source?
No. It's you can go to vector.dev. I think it somehow belongs to Datadog, and we just discovered it by accident. Actually, we're using Fluent Bit or Fluent D. Which one is the Ruby one? Like the Ruby one, and it was very slow, sadly, because we had increasing number of logs, and yeah, Vector really saved us. But yeah, it's open source. It's not from us. It's very good.
Do you think developers would feel more confident to manage configuration using predefined manifest? Could be manifest CRD?
Okay, you mean like a CRD which only exposes the options? Sure, but then you need some controller again which would read and interpret these CRDs, and this is what an ingress controller does with the ingress resource. So I don't think there's extra value in that, but maybe I'm understanding the question.
Sure. And if you're able to disclose, how many logs per second do you process via Vector?
Well, it's one line usually per request. So yes, for us, it's probably, if we split it up, several thousand per second usually. And yeah, it just works. By the way, Vector uses more CPU than the HAProxy instance it's attached to does. But yeah, with other log parsers, I think it would be even worse. And we do a lot of processing steps in there. Probably if you just parse them and ship them, it's way less.
Awesome. Well, thank you so much, Philip. Give it up for Philip. Thank you.